Hello everyone, today I'd like to give a little bit of an intro as to what we're here doing today in this workshop. So in essence what we're doing is we're mounting strain gauges to our ASTM D638 standard tensile specimens. For those of you who don't know what a strain gauge is, it is in essence a sensor that records changes in resistance in response to some sort of applied force. So you mount these to our specimens, we apply a force, we see a change in resistance within the strain gauges themselves, and then our data comes back in the form of stress or strain. The stress or strain then is used to both validate our current system, as well as then be used to record values for future applications or future tests. So like I said before, this D638 specimen is actually composed of a polyamide 11 and has a carbon fiber and glass fiber filler. In order to actually bond these strain gauges to these samples, we're having to utilize an M-Bond 610 kit. And this M-Bond 610 is actually an adhesive. It's a two-component solvent-thinned epoxy phenolic adhesive, which operates in a very wide temperature range, all the way down to negative 452 degrees Fahrenheit and up to 500 degrees Fahrenheit, which is why it's ideal for the application of cryogenic mechanical testing. It also maintains a pot life of about 6 weeks at room temperature, which permits the idea of mixing and then, 6 weeks later still being able to use this adhesive before it becomes expired past its due date. All right, so for the first step, we're going to get our sample and put it on our workstation. And you just grab it out with your tweezers. And you place it with, it's hard to see, but with terminal side up, it's a little kind of just bump that comes out of the surface. Plus two, you'll see it with a lot more clarity on the front facing side versus the back facing side. But you want the terminals facing up because that's the side that you're going to be doing all of the cleaning to. So you go ahead and put that there. I would recommend holding down the strain gauge as you spray it, just because the strain gauge is so light that it'll actually just go away with the force of this. So I'd recommend doing that. You can kind of do it generously. And then with this, like I had said, with the cleaning of the workstation, you want to do it in one fell swipe just so you can get it off and not contaminate. So I'd recommend doing it this direction. You can do it again just as long as you use a different side of the gauze. So what you're going to do is you're going to abrade to a matte finish. And so just for simpler terms, a matte finish is generally about 10 to 12 strokes. So that 10 to 12 strokes is just one motion, that's one, two motion, that's two, three motion, that's three. And you're going to do that to specifically the mid-region of the sample, seeing as the rest of it doesn't really matter too much. Since it's so small, you can go ahead and just get the whole sample if you want to. But 10 to 12 strokes back and forth is what we're doing here for both samples. And to first start off with doing is applying the M-Prep Conditioner A, which is the one in the red tip, just for you guys out there. And then what we're going to do is we're going to use this in unison with the cotton applicator. And to save on these, just because there's not as many, there's still quite a bit, but just for future use, what you're going to do is you're going to squirt it on the surface basically, and then rub it on one side. And then obviously you're going to have some sort of black that comes up from it. And so what I'd recommend is squirting more on, flipping it 180 degrees on the tip, and just rubbing the other side. The goal is you're trying to get it to the point where there's no black that shows up on the tip itself. Again, this step in combination with the next step, we're trying to get done as fast as possible. Not like 10 seconds here or there is really going to make that much of a difference, but just try to be faster about it just so it doesn't absorb into the sample itself. So I'll go ahead and do that here, just verifying my words to make sure I'm not doing anything incorrectly. So you can use it pretty sparingly, kind of just drench the thing. And then wipe the surface. And you'll see it's a little bit darker. I know you probably can't see anything on there, but it's slightly darker. So I'll go ahead and do it just once more, just to be certain. Like so. And then again, like previous, you're going to, with a single stroke, just wipe it off the sample and then try to clean it up off the surface as well. So same thing as last step, just a different applicant. This time we're using the M-Prep Neutralizer, which gets us to the desired alkalinity on the surface that we're looking for. So exactly the same. Just kind of generously apply. And the whole time you're doing this, it's best to keep it just really wet. Soaked. Just soaked. And then you're going to, with one stroke, swipe like that. And then I'll also just go ahead and give it to the other guys as well. Try to cut along those dots. And this is going to be very difficult, and it might take a little bit. And then you're going to also have to cut towards the soldering tabs. And then you can even cut off this base part here, because there's nothing to do with that, or there's no reason to keep that necessarily. The reason that we have to stay outside of a 5 mil threshold is because if you cut any closer, you'll actually get residual stresses that build up in the actual strain gauges, which then can lead to bad results or faulty results later on. So what we're going to use here is the PDT-3 drafting tape. And what I would suggest doing, and if you guys think of a better way to do this, by all means, you can stick it to the actual surface of it. What I would do is you're going to stick it down half of it, like that. And then you're going to stick a piece on the side that you're actually cutting off. So that way it's held taut from both sides as you cut with the X-Acto knife. And on this side, obviously, you're going to have to tape it really, really close because you're trying to leave the little window that you're cutting. And then what you're going to do is you're going to cut on the one side, and then once you cut to what you think is close enough, you're going to just repeat the process on the other side. So I put the Mylar tape down, and then you can peel up at a shallow angle, and then the strain gauge comes up with it, like so. And then what you go ahead and do is you're going to place it, and this is where those layout lines would have come in handy, but again, it's really hard to do that on this size of sample and the strain gauge being a little bit bigger. So what I would suggest doing is just, as we're doing right here, is you just lay it down, and again, you can adjust this later because we haven't actually obviously adhered anything yet. I'd recommend peeling up from the non-terminal side, because that's mostly where the adhesive is being applied, is on the gauge length. The next step you're going to do is you're going to take this. This is your phenolic adhesive. So you're going to coat it with a very thin layer. Like so. And try to limit the amount of contact between the brush and the tape. I'm going to do a little bit more just to make sure we have full coverage. So what you're going to do is place it down as best as you can. Put the tape back down and make sure you position the strain gauge in the place that you need it to go. So I would use some pressure, some hand pressure, so that way it sticks. Maybe let it sit there for a sec, and then you should be able to, if you hold this, I'd recommend holding the sample or the strain gauge down. You should then be able to peel back the tape and just leave the strain gauge. So then we're going to go ahead and let this cure, or air dry I should say, for 5 to 30 minutes. I just let it air dry for 5 minutes. It's a little sandwich of Teflon, rubber, then metal, and we're going to do the same thing on the underside, except we are only going to be using the rubber and the metal. Because there's no need to do all three. We'll do it like that. And you want that clamp to be somewhat
centralized.
Yeah. That is the completed sandwich. Once we have our strain gauges actually placed on the samples themselves and we have applied the clamping force to each sample, the next step is to then go ahead and place all the samples in an oven, whereby we will cure from room temperature up to 325 degrees Fahrenheit at a rate of between 5 degrees Fahrenheit per minute and 20 degrees Fahrenheit per minute. So somewhere within that threshold, we reach 325 degrees Fahrenheit. And then we cure at that temperature for 2 hours, whereby we completely cut the power and we reduce the temperature down to 100 degrees Fahrenheit before removing these samples. This is what a specimen looks like just out of the oven post-cure operations. You'll notice that the strain gauge itself is completely cured to the midsection of the specimen itself. So then proceedingly, we're going to be using the tin lead antimony solder to solder a specified length of 326 DFE conductor cable. On the final specimen, I have an example of one that's post-solder. you'll notice that there are 3 cables, black, white, and red. The red cable gets soldered to one terminal, while the black and white get soldered to their own independent terminal. So with the finishing of the soldering operations, we are good to go ahead and actually put the sample inside of the testing chamber within our cryogenic accelerated fatigue tester. So with that, I hope you all have enjoyed this little instructional how-to. If you have any questions, feel free to reach out to me directly or just message me via Teams. Thank you for listening and watching.